Okay, so let us start with further topics like we have studied about the onboarding of the devices, how to onboard the devices, how to onboard the WAN edges, the vSmart, the controllers, and all those stuff. Okay, let us go more in depth about the things. Okay, so what do you mean by VPN? Does anyone know what do you mean by VPN? What is VPN?
VPN is a secured tunnel.
Okay.
So we have a when we have a unsecured network like internet, we can build a secured. We can send our traffic securely over the IPsec VPN.
Mm-hmm.
It will be encrypted. The traffic will be encrypted when it is sent over the VPN. Yeah.
Okay. So VPN is something like so in this SD-WAN part we have VPN uh, definition is like your VLANs. Okay, so as I've given you an example in the previous sessions also that the VPN is like your VLAN. So if you if you want to distribute your network on the switch, what you do, you make the users in different, you make different VLANs and you add the users in different VLANs. Okay. So in the same way, we have VPNs over here. So VPNs will be always on the WAN side. Okay. This will be always on the WAN side. WAN side in the sense, suppose if you have, if I give you an example, if I have this branch one, so this interface will be in a VPN. Okay. If this interface will be in one VPN, suppose this interface is in another VPN. Okay. Now
Okay.
these interfaces are in one VPN. This is in another VPN. Okay, this is how it is working. So it will be VPN 0 is always the WAN side VPN. Okay,
Okay.
so now you can have multiple WAN VPN, multiple, you can say in VPN 0, you can have multiple WAN services. Suppose in this example, we only have a service provider over here. Instead of service provider, I can have something like this. I can have an MPLS connectivity also. So here I can have MPLS. Okay, MPLS connectivity. And this is now again in turn connected with this router like this. Okay, so this is what redundancy. What do you know? What do you call as redundancy? So for big organization, we need to have scalability and we need to have redundancy over here. Okay, so for redundancy, we can have either we can have one WAN service, either we can have only internet, or we can have multiple WAN services also. So here we can have in this way we can have multiple WAN services. So if one VPN wants to communicate with another, means if anything, if suppose these two colors are same, pink and pink, we manage 14 gig 0/0 and 0/1. These have same color. I have given them same color purposely because they can communicate with each other. They can communicate with each other without any configuration. So like two VLAN users can communicate with each other without any configuration. Okay, we can have two VPNs. Users can communicate with each other. So now here we have this router. Suppose here we have some router connected, and on that router we have some users connected over here, and here also some users are connected. So if one user wants to communicate with another user in the same VPN, okay, they can communicate and they will be communicating over the tunnel. Okay, now the tunnel will be formed and these information will be shared with the vSmart, and vSmart will be the controller that will control all the informations. Now, this is something a rough idea about the VPNs. Okay, VPNs are nothing but like VLANs. Okay, VLANs in the sense they are then you can say they are just an example. You can say like the VLANs. Okay, now this interface is another VPN. This interface is another VPN. And now this if VH15 wants to communicate with VH14, they will not be able to communicate because they are in different VPNs. Okay, so now we will be studying about these all things later on. Okay, how they can communicate and all those stuff. Now you can see over here, these are the controllers. These are what controllers. These will control the traffic. Okay, every controller will have its own what do you say? task, okay, or you can say they have their own operations to perform. But if you see, this vBond is having gig interface. Rest other two these are having what? Ethernet interfaces. Okay. Now, why this is having gig interface? Because the vBond itself in virtual environment, like in EVE-NG, I have installed this in virtual environment. vBond will use the WAN edge images. Okay, WAN edge will have gigabit interfaces. So here vBond is also using WAN edge interfaces. Okay, means WAN edge image by default it uses the WAN edge image only. Okay, vEdge image only. So you don't have any separate image for vBond. Like we have a separate image for vSmart, we have a separate image for vManage. You don't have a separate image for vBond. You will be using the same image as your vManage. Sorry, vEdge. Okay. Now, if you want to see, you can go inside this VANEdge, so the vBond, and you can say like show interface. If you give this command show interface, you will see these are the interfaces that are interface VPN. This is the interface that is part of VPN 0. Okay, gig 0/0. Okay, and this is an address family type IPv4. This is the IP address on the interface. Okay, all these details are given over here. So this has only one interface, which is gig 0/0, and it is connected. Now, if you go on other controllers, suppose if I go on vManage, and if I say here the same command, show interfaces or show interface. Now you can see over here, there is one interface, ETH0, which is part of VPN 0. This is the IP address. This is admin status up, operational status is up. Okay, this is port type. This is a transport VPN. Now, as I've given you an overview of the transport VPN, and we can make any of the one VPN, either VPN 0 as the transport, or we can make VPN 512 as the transport. These are the two default VPNs that we have. So we need to select which VPN we need to make it as transport, or which of the VPN we need to make it as either management or backup. So here we have this as the transport VPN. Okay. Show interface. This is the transport VPN here. Okay.
Yeah. Yes.
This is the IP address, and these are the received packets, transferred packets. Okay. Here you will see that ETH1 is also a part of VPN 0. Okay. Here ETH1 is also a part of VPN 0. So you can make it as a part of VPN 512 also. Now let us go on vSmart also and check the same thing. Show interface. On the vSmart also you will see VPN 0 as ETH0. It is operational status is down. It is not used. Okay, status is up, but operational status is down. Whereas ETH1 is connected. If you see, ETH1 is connected. Okay, which is being used. ETH1 is connected, which is been used over here. Okay, VPN 0. Now, how these traffic are being flowed means how the traffic is being flowed, how the traffic between the routers, between these devices has been flowed. So you need some routing protocols. So now these images that I am using, these are some 18 dot images, 18.3 dot or 18.4.4. Okay, so 18 dot version supports static routing. It supports OSPF and it supports BGP as a routing protocol for your communication between the devices. Okay, underlay you can say. So it supports your BGP, OSPF, and static routing. Now in the latest version, that is 20, they have also added, as you know, that this is Cisco proprietary now. Okay, means not Cisco proprietary. You can say it is Cisco has over means they have they have taken up the Viptela. Okay, so now they have added their proprietary protocol also, EIGRP. Okay, the support for EIGRP is also added in the latest images, latest version like 20 or 21. I don't know exactly the version. So 20 dot something is there, in which your latest or Cisco proprietary EIGRP support routing protocol is also added. Okay, now what? Now suppose if what I said, this is my one interface, this is my one interface in a VPN. Now if suppose there is a route added over here, okay, there is a route added over here, okay, there is some network added over here, or there is a small network added over here. Now this network information needs to be shared with VH10 also, because VH10 needs to reach over here. So how it will be sharing the network information? What do you think? How it will share the network information to the other VHs in the same network?
So
How
I
it will
think
be sharing the network information?
it will be using a OMP protocol, if I'm not wrong,
Yes,
to
correct.
address the.
So it will be using something known as OMP, Overlay Management Protocol. Now, what do you mean by OMP, Overlay Management Protocol? Now, this is like your routing protocol. Now, this is your Viptela proprietary protocol for SD-WAN. Okay, this is a routing protocol for SD-WAN traffic. Okay, SD-WAN traffic. Now, like your Cisco has EIGRP as a proprietary. This was proprietary for Viptela. This is proprietary for Viptela, OMP, Overlay Management Protocol, OMP. Okay, via OMP, this route information will be given to WAN edge 10. Now, how the route information is shared? This route information is not shared directly to the other WAN edge. It is not directly shared to the other WAN edge. What it is, where it is shared with the vSmart. Okay, so I'll share the information with the vSmart. I'll say, okay, this is my network X. Okay, network X. Now this is my network X, and you have to keep the network X information, and it will share network X. And suppose this is my VPN 10, so it will share that this is coming from VPN 10. Now what vSmart will do, vSmart will store this information, and vSmart knows that where all the VPN 10 is running. So now vSmart will share the information to the WAN edge that is the part of VPN 10. Okay, so every traffic will go to the vSmart OMP, Overlay Management Protocol. Okay, now your underlay, what is your underlay? Underlay is your this traffic. The traffic is like this. This is the underlay traffic. Okay, your via the internet. This is your underlay traffic. This is not your overlay. Overlay means there will be a tunnel formed between the vSmart and the V edges. Overlay tunnel. Overlay. This is like your you can say your
DTLS.
hub and spoke topology. DMVPN, you can say hub and spoke or DMVPN. Okay, like your DMVPN, it will be. Okay, now this OMP is TCP based. TCP based. TCP protocol. Okay, the transmission control protocol. Now we don't have any port numbers as of now. I mean I don't know the port number of this. Okay, I've been looking for this, but I did not got the port number. Okay, so it is TCP based, but these ports are hidden for OMP. Okay, got it?
Yes.
Any questions?
So actually, the DTLS tunnel and TLS tunnel are there, right? So that will be in underlay. How that will?
The DTLS tunnel will be overlain. They will be not underlay. They will be like your every traffic will be your the traffic will be secured. This green means secured. Okay, so it will be running over IPsec. Everything will be over IPsec. Okay. Now DTLS, where is between which devices do you have DTLS tunnels?
So it will be between the controller and the VHS.
Controller and the WAN edges. Okay.
Well,
So an IPsec between the WAN edges. Correct. So every traffic over here will be either IPsec or DTLS.
okay.
Okay, I just gave you an example like this will be like your DMVPN. So DMVPN means we will be using some IPsec. This is not DMVPN, but this is like your DMVPN. Okay, OMP.
Okay. Fine. Got it.
Okay. So this is your IPsec traffic, and now where do you think this OMP will be running? Between which devices this OMP is running?
So it should be on all the devices like WAN edges, all the WAN routers.
Okay, all the WAN edges too. Can you speak a bit louder, please?
Okay. Is it better now? Am I audible better?
Yes. Now it's fine.
Yeah. Okay. Between the WAN edges to all the vSmart, mainly to
Okay,
the
like this
vSmart, I
you're
think.
saying.
Yeah.
vSmart, vBond, and vManage.
Yes.
Okay. No, this is not the C. The traffic, the OMP will be only between vSmart and the WAN edges.
Okay.
Okay, OMP will be between vSmart and the WAN edges. I'll just show you. So OMP runs between vSmart and the WAN edges, like same your hub and spoke topology. Okay, so I'll just show you something. So you can see over here in the dashboard in the last session we have onboarded all the WAN edges over here. Now if you see the option over here, monitor, the first option, monitor, if you go under network, you will see these all devices are there, and these are the site IDs, these are their VFD, these are the control planes, these are the connected devices. Okay, now I'll go under vSmart. I'll see these options of the vSmart. I'll on the left hand side, I'll scroll down and I'll go in the last option, real time. Real time. I'll click on this. System information, under system information, I'll just type OMP. I'll say OMP peers. Now you will see OMP peers over here are my 4 WAN edges. What are the OMP peers? My 4 WAN edges. It is giving me that these are up. These are legit. Yes, these are my peers. These are the WAN edges. Okay, these are their site IDs. These are their domain. Okay, so OMP will be running between only WAN edge and the vSmart. Okay, WAN edge and the vSmart. If you want to see, you can go again in the network and you go on any of the VH. VH to VH, there will be no OMP. If you want to see, go again in the VH and go to real time and again search OMP. Here you will see OMP is only between WAN edge and the vSmart. So OMP will be between only WAN edge and the vSmart. It will be running, like I said, hub and spoke topology. It will be running between the WAN edge and the vSmart. Okay. Now,
Yes.
if like we have studied in previous sessions that we, for redundancy or for scalability, for redundancy purposes, we need to have multiple vSmart. So if we have multiple vSmart, then suppose if I have like this, if I have one vSmart over here in one location, one vSmart in another location, okay, vSmart, 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 and here we have WAN edges, okay, WAN edges, here we have WAN edges. So these vSmarts, WAN edges, these will be having, also these vSmart will have OMP tunnels between them. Okay, so if there are multiple vSmart, then OMP will be running between them also. Got it? If these are multiple vSmart, so multiple vSmart, why do we need? We need multiple vSmart because we need redundancy, we need backup. And if you go and buy a SD-WAN solution from Cisco, they will recommend and they will say that means they will give you at least three vSmart. Okay, they will say you need at least 3 vSmart licenses or 3 vSmart devices. Okay, and these vSmart devices should be kept in different locations. So like there is no use of keeping these all 3 vSmart in one location. Why? Because if suppose this vSmart goes down, okay, or this site goes down, then other vSmart can handle the traffic. Other vSmart can handle the traffic. Like if in our scenario we see, if in our scenario, in our lab scenario, so I have just kept one vSmart. Okay, so suppose there was one X network I said, and it was shared to the vSmart. Okay, then vSmart, what it did, it shared to the WAN edge for the particular VPN. Now, after which the vSmart went down. Now, will this WAN edge be able to communicate to this network X? What do you see? Will it be able to communicate with this network X?
Okay, maybe there will be some time till that the route is available, or until the VH gets rebooted. The routes will be available in that VH, so it can able to communicate. But if
Correct,
there are any new routes, it will not be able to populate or advertise those.
correct, correct. So now, if vSmart has given any route in the to the WAN edge, it will store it in where? Routing table. Until this WAN edge has the information about the router X in the routing table, it will be able to reach, even though if the vSmart is down. Even though if the vSmart is down. Now, if there is a network Y added and the vSmart is down, now this WAN edge will not be able to reach this network Y because the vSmart is down. That is the reason it is recommended to keep multiple vSmarts. Okay, so if one vSmart go down, this network information can be shared to the other vSmart, and this other vSmart can share the information to the WAN edges. That is the reason we recommend to have multiple vSmart. Okay, multiple vSmart, at least 3 vSmart Cisco recommends. You should have at least 3 vSmart. So not all the 3 locations will go down at once. Okay. So if one goes down, another vSmart can take over. If another two, both of, if two goes down, then third one can take care of the routing. Okay, of the control plane, you can say. So even though my control, even though my control plane is down, and if I'm not having backup, still, if my routing information is present in the WAN edge in the routing table, which was previously shared, I can reach, the WAN edge can communicate with the other WAN edge. Got it?
Yes.
Understood?
Yes, clear. Understood.
Now, so okay, so I said you that this WAN edge information, the WAN edge sends the information to the vSmart. Okay, so what information does it share? Okay, what all information does it share? So first thing it will say, okay, I have a network X. So first information, this is network X. What will be the second information that it will share?
Okay,
What do you
VPN.
think based on basic networking? Okay, what do you think a router will share?
Okay, the maybe the next hop IP information.
Okay, next hop.
So it is part of which VPN?
Yes, it is part of which VPN. So suppose first we shared what
A network.
which network, it is part of which VPN, and the next hop. Now what will be your next hop? The connected interface in that particular VPN. So this
Yeah.
interface, you can say this interface IP will be
Yeah.
your it means this will be your next hop, right?
Is correct. Yeah.
In basic networking. But here the term changes. Here the scenario changes. Here we have, instead of next hop, we will have something known as TLOC.
Okay.
We have something known as TLOC. Now what do you mean by TLOC? TLOC is nothing but your, as a next hop only, transport locator. This is your transport locator. The full form of TLOC is transport locator. This is something like your next hop only, but it will have some more information. Okay, it will have more information. What information? It is there in TLOC. So first thing that we will, the WAN edge will share is network, which VPN it is part, and the third is TLOC. Now, what is there in TLOC? TLOC has 3 informations. First thing, it will have system IP. system IP. Okay, the system, every WAN edge will have its system IP. Second thing, it will have color. Second thing, it will have color. Third thing, it will have encapsulation. Encapsulation. Now, encapsulation will be IPsec. Okay, this is default. System IP is default, means system IP, every WAN edge will have its own system IP. Okay, every WAN edge will have the encapsulation running IPsec. This is the new term, color. What do you mean by color?
Color is whether it defines whether it is an internet link or what type of circuit, maybe if
Color,
MPLS circuit.
yes. So color means WAN service, basically. WAN service. Either it can be internet, or it can be MPLS, or it can be anything else. Okay, it means WAN service. Color means which WAN service we are using. Which WAN service we are using. Okay.
Okay.
Now,
yes, clear.
These informations will be shared to the vSmart. Now, every WAN edge will be known by its TLOC in the network. Every WAN edge will be known by its TLOC. So TLOC has which information? So if I want to reach, suppose, any WAN edge, so this information will be shared to this WAN edge. So if I want to reach, if in this routing table of this WAN edge 10, I'll have the TLOC of what? If I want to reach X, I have to go to this TLOC. In this way, we will be having the information in the routing table. Now, one WAN edge can have multiple TLOC. Okay, based on as I said, it can have multiple TLOCs. Like if this WAN edge is there, I can be having another WAN edge connected. So one is connected to the service provider or ISP, you can say. One is connected to the MPLS. So now I will be having two colors. Okay, one, this interface is a part of service provider, this interface, and another interface, this interface is part of MPLS. Okay, so now TLOC will have two colors. System IP, now it will have two informations. System IP will be same. Now what will change? Color will change over here. First was service provider, now it will become, second one will be MPLS. Encryption will be same. Okay, now what is the benefit of this, having two WAN services? So the benefit of this having two WAN services, that this WAN edge will say to vSmart that I have two TLOCs. That means you can reach to me via these two colors, these two mediums. Okay, you can reach to me via these two TLOCs. I have two paths. Okay, this is something useful for scalability or redundancy purposes. So if I am having one TLOC, if that WAN service is down, this WAN edge will not be able to reach. Okay, if I have two WAN services, the other devices can reach this WAN service. Okay, this is what the TLOC is. TLOC is basically used for redundancy purposes, you can say, to scale your network. Okay, scalability, for scalability, we use something known as TLOC. Understood?
Yes. So this TLOC information will be stored in like a routing table format, like how that.
Yes, it will be stored in the routing table.
Routing table. Okay. And suppose, like mentioned, there will be two TLOCs. If there are two TLOCs to reach.
Just give me a second. Your voice is very low. Can you speak a bit louder, please?
Is it better now?
Yes, it's better now. Thank you.
Okay. If there are two TLOCs to reach one specific subnet, one via internet, one via MPLS, which will be preferred? Like how that will be preference? Whether it depends on how that will be chosen.
That we will come to the in the future part. Okay, I'll come to that. I'll show you practically if we have two TLOCs. how it will be, how the devices will be reachable, how it will be reachable. We'll see that. Don't worry.
Okay, sure.
Okay.
Yes,
So
fine. Yeah.
vSmart, what is vSmart? vSmart only has the control plane. Okay, so whatever information the WAN edges will be sharing, they will share with only the vSmart, and the vSmart will then share the information with the other WAN edges, okay, which are part of that particular VPN. Okay.
Yes.
So this is what the TLOC and all these informations are there. Okay, so okay. Now we have all these WAN edges up. Now, what all information do you think are common information that you can reuse? Okay, suppose if I have these many WAN edges, I need to configure. So the SD-WAN solution is for scalability. Okay, and so what do you think? What are the information that we can reuse over here on that can be common on all the WAN edges?
Uh, okay. I mean, is it with respect to TLOC? I did not
No,
get that.
not TLOG. TLOG is finished now. So
Okay.
any information that should be common, that will be common on all these WAN edges. We can suppose if I have on all the WAN edges I have what VPN 0, correct?
Yeah. Yes.
On WAN edges I have what VPN 512. By default, all the WAN edges will have what system information. System information will include system IP, site ID, etc. Correct?
Yeah.
These informations are common information, reusable information, you can say. How I can now either I can go on each devices like I did. I did in the previous session. I went into the CLI. I went into the CLI. I configured all the devices VPN 0, 512 and system info. I've configured all the devices. So what is the use of SD-WAN then? I manually configured via CLI. Why the SD-WAN came into picture? So what I can do instead of going on each device and adding those details, I can create something known as templates. Templates. Okay, so as I said, everybody will be having what? Everybody will be having VPN 0. Everybody will be having VPN 512. Everybody will be having system info. So what I'll do, I'll create some VPN. So I'll create, I'll create templates. Now, what do you mean by templates?
Template is like creating kind of a policy or what are the parameters which can be applied. Uh, no, we can specific parameters we can define and we can keep it like a policy and that can be pushed to multiple devices or we can use it whenever we need it. Latest.
Correct. So you can say the reusable things, whatever reusable things are there or whatever common things are there, we can add them and we can create a single template. We can create a template and we can apply them on multiple devices whenever we want. Instead of going on each device, and so only once we need to create a template and we can apply it on multiple devices as many times as I want. Okay, if we have 10 devices for today and in future if I had more 10 devices, I can simply add the templates for that on that 10 devices and I can configure that 10 devices with this template. So I have to only create the template once and I can reuse it multiple times. Got it?
Oh yes, clear. Understood.
Okay, so these are common features that we need to we are having in this. So now there are two types of templates over here. Two types of templates. One is what? Device template. And one is what? Feature template. One is device template and one is feature template. These are nothing but feature templates. VPN 0 is one feature template. 512 is one feature template. system info is one feature template. Combining these feature template, we create one what? Device template. Combining and using these feature templates, we get what? A device template. Combining all these feature templates, we will create one device template. Okay, like if I go on the vManage, we have templates over here. So here we have, if you remember, we have created some device template and some feature templates. Okay, so I did created VPN 0 for WAN Edge. I attached one device. Okay, but currently I'm not using it. Okay, so these are the feature templates that we are using. I'll edit. So what I'll do, I'll just, okay, so VPN 0. Okay, VPN 0 template, VPN 0 name is VPN 0, ID is VPN 0. Okay, now nothing else I need over here. I don't need any static. If I want to add any BGP under VPN 0 static, I want to advertise anything under OMP. This is OMP, advertise anything under OMP. I can advertise it over here if I want to add any route. So I want to add a default route that is pointing to the next stop. What is the next stop? The next stop is my uh, gateway router. Okay, so I have added this. Okay, now what will be there in the device template? In the device template, you will be having something like, if I edit, you will be having system information. So I have not created a system template. So I'll go and create a feature template for system. I can create a feature template. I'll say, I can give any name as I want. Okay, I'll say system. Here also I'll say system. So this is what I have to just create the template at once and I can push it in the multiple devices. Okay, so site ID, if I have only one device in particular location, I can globally assign it. What does this mean? Global means I can assign it at this moment. Device specific means I can assign it while, if I want to apply this system template on multiple locations or for multiple devices, I can keep the site ID as device specific. You're also device specific. Overlay time zone I can configure. Host name I can configure. Location I can specify the location also over here. Okay, so by default it will be default in the default, so it will not, I can specify the location. Okay, location in the sense I can say device specific I can keep. Okay, so like location I can say branch 1, branch 2 or something. I can configure over here. Baud rate I can set. Okay, baud rate I'll set something. I can set I'll set 38,400 as of now. Latitude and longitude you can set for GPS locations. Okay, you can add trackers. You can add in the advanced, you can add MTU, DTLS tunnel. These are default things. If you want to add it, you can add these all things. Okay. Wherever you see this global sign, that is something you need to enter the detail. Default means you can keep them as default. No need to enter. Compulsory. These are not compulsory. Wherever you see global. So in baud rate, it was by default global. So if I don't enter this, it will not get saved. I need to enter something or something else. Okay. So I need to select something over here as a baud rate. So global means it is mandatory. Default means it is not mandatory. If you don't select anything, then also it is fine. It will keep the default information. Okay, save. Fail to create template with name system is already exist. Okay, system is already exist. Let me check what is there in system. I'll go in the feature template. Okay, system is there over here. I have already created the system template. Edit. Okay, site ID is 200. So here I have kept it as okay. So basically combining these, you will see over here in device template, what we have multiple feature templates. So system template is there. Then we have transport and management VPN, which is 512, and sorry, VPN 0. And this is my management VPN, which is 512. Okay, so if I want to keep any if I want to keep any template if I want to select any feature template, I can select from here. Okay, I can add service VPNs also over here. If I want to create any extra VPNs, I can create it from here. Okay, if I want to add some banner, if I want to add some policy, SNMP, security, I can add those details from here. Okay, these are the information. So basically, as I said, two types of templates. One is device and one is feature. Feature are separate templates, small templates you can say, and device is your all the feature templates will be combined and formed a device template. All the feature templates will be combined and form the device template. Now, can we have multiple device templates? Yes, we can have multiple device templates. So this is device template for branch 1, suppose. This is device template for branch 2. I'll have another feature templates in these for these. Got it? We can
Yes.
have, sorry?
You got it. So, yeah.
We can have a device template for vSmart. Okay, like if I want to create a device template for vSmart, I can create a device template for vSmart also. Okay, like if I show you over here, if I suppose want to create a device template for vSmart, I'll go in devices, I'll go in controller, and I'll say, see, this is also one way to create a device template. Okay, so I'll go on the vSmart, I'll say running configuration. I'll copy whatever is there in the running configuration. I'll select all the things. I'll go in templates. Under device template, I'll say create a template either from feature template or from CLI template. So I'll select CLI template. I want to create a vSmart template. I'll say vSmart. vSmart. Whatever CLI configuration I've copied, I'll paste it over here. Okay. And I'll click on add. Then feature and device template. Now I will add, I'll say attach device. I'll configure, I'll bring this vSmart on the right hand side, attach. Now what I'm doing, I'm configuring. Now here you can check the configuration. So config preview can be checked over here. Okay. So here you will see what you are configuring. Here you can see what you are configuring, exactly what you are configuring. You can see the difference also over here. The difference in the sense you can see what was pre-configured and what you are configuring now. Okay, so here I'll say side by side difference. So this is local configuration and this is new configuration. So previously it was having this chassis number. Currently it will not have the chassis number. Previously it was having MTU. Now it is not having any MTU. And this is the new configuration. Previously it was having color and these information. Now it has been removed. Okay. So like you can see the difference of the command over here. What is the difference between the configuration that you are pushing and the previous configuration? Okay. So configure devices. Now it will push the configuration to the vSmart. Success. Now you go on the templates and you will see one device is attached over here. There are no feature templates. Okay, there are no feature templates, but this is also a type of, so you can see over here, this device is configured with the CLI type of template. This is configured, this device template is with feature templates. Understood?
Yes.
Okay. So now we can have, as I said, we can have multiple device templates and multiple feature templates, as I said. So like this example, I can have WAN edges. Okay, I can have multiple WAN edges, multiple feature templates for multiple WAN edges. Okay, so feature template 1 will be for these WAN edges. Okay, and these feature templates. Now, so I can distribute them, like some of the feature templates will be applied to only these WAN edges. So I'll add them as one in the one device template, and another device template I'll create for another set of WAN edges. So feature templates are nothing but features that needs to be added on the WAN edges. Okay, in this way you can create multiple device templates. Okay.
Understood.
Okay, so in the next session we'll see how to create these templates, how to push the configuration on from the by creating. So previously we have seen via the CLI. Now we will try to push the configuration from the vManage. We'll create some templates like VPN 0 template, VPN 512 template, system templates, and we'll push it from the vManage. Okay, got it?
Yes. Got it.
Okay then, so we'll meet tomorrow. Okay.
Sure.
Okay, bye, take care and be safe.
Yeah. Thanks for your time.
Thank you.